2, 1. Okay, so welcome for another one. So here we're going to be studying equivalent trigonometric functions. It's kind of part 1. When I guess finish part 2, maybe I'll put up a link up above there to that. I didn't want to mush it all into one video. I think it would have been too long and just too many concepts. So here what I want to try to do is take these trigonometric functions, and when you're working on equivalence, which basically means, you know, something is equal to something else, then with having these trigonometric functions being periodic, we can find a lot of different functions that are actually equivalent. So as you can see here, for instance, I wrote out the 3, so sine, cos, and tangent. They are all equal to, you know, so for example, sine x is equal to sine of x plus 2n pi. Now that n, notice it's an element of integers. And that should make sense, right? Because our sine function, and then the same thing for cosines and tangent, and for cosecant, secant, and cotangent, well, they're periodic. So if we're going to be shifting them left or right by 2 pi, then we're not really doing anything. It's exactly the same function that we have. So they're certainly equivalent, right? So if I would show you this on Desmos, let me pull it up. All right, so here is Desmos, right? So if I put in, let's say, sine of x, okay, so here it is. Let me kind of blow it up a little bit higher. And then I'm going to put in sine, and, you know, so this is going to be x plus, you know, if I just put 2 pi, so notice that it just overlaps our original, okay? And now, so any, you know, so if I multiply this by n, okay, so I'll just put it like this, okay? So I'll do that, and, you know, so here I can put, if I put, so this, if this is 1, if it's minus 1, all right, minus 2, minus 3, okay, you know, 10, doesn't matter. If I just keep shifting it, it just overlaps exactly the same function. So all of these are certainly equivalent statements of each other. And the same thing you can do with secants, cosecants, all right, cotangent. So any of those that we put in here. So if I put in, instead of having sine, you know, I'll put in, let's say, cosecant. And then I'm going to put cosecant here. Okay, so notice they just right away overlap each other. So that's the first thing in terms of equivalence. And that you should remember. You know, this one isn't that hard to remember. Like if you're going to shift the trigonometric functions by 2 pi or some multiple of 2 pi to the left or to the right. So basically it's just a translation. It's just that period. So those are going to be the same. So that's the first item that I wanted to point out. The second item that I wanted to point out is when you're translating by pi over 2, all right? And so this is interesting, and this is not always as easy to remember, to be honest with you, okay? So, I mean, I kind of remember this pi over 2 visually, you know, so I am very familiar with having sines and cos, and I know how they look like. And so if I plot these back in here, so let me remove this junk for the moment. So let's say, let's maybe call this f of x equals sine x. And so here it is. Shift this over so we have it, you know, nicely. And then I'll put g of x is equal to cos of x. All right, so here they are, right? And as you can see, so this is all in radians. We can change it back to degrees, so that pi over 2 just means 90 degrees. So you'll notice that sine x on the left-hand side, okay, so if I take it in here, sine x is equal to cos of x minus pi over 2. So this is just translating, right? So think about cos. So cos is the black one on the screen there. And if we're going to be translating it pi over 2, which really just meaning a shift to the right, okay, as you can see, they're going to be lining up on top of each other. So they're going to be the same. Right, so if I take this and then I just translate it as pi over 2, like this, notice that it just right away shifts over and basically becomes my sine. So that translation, again, it's not super simple to try to remember, but always visualize, okay, if you're going to be asked these, okay, these equivalent functions. Okay, so sine, okay, then you need cos, and then it's just being translated by pi over 2 to the right. And the one below it, so if you start with cos, so if we started with cos in here, so let me go back to that. And now I wanted to find the equivalence in terms of sine. Well, then of course I can take the sine, which is the purple, and now I can shift it to the left by pi over 2. So that's why I have sine x plus pi over 2, right? Because translation is that sine has to be the opposite. So if I do that, you know, so if I take this and now I say, you know, plus pi, okay, and now it's over 2, notice that it aligns with my cos exactly. So that's the second equivalence, right? So what we have is our first equivalence happens when we are just shifting the regular function by 2 pi or a multiple of 2 pi to the left or to the right. Really, again, it's just a translation, but it's by the entire period of the same function. And, you know, you can write the cosecants and secants and cotangents there as well. They're all equivalent. Okay, the second one that you kind of run into in terms of equivalence is just the translation between sine and cos by pi over 2. And, you know, please remember that if it's a translation by pi over 2, that means I can also translate by another. So, you know, what I can do here is, okay, yeah, so even and odd, we'll do that last. But if I take this, for instance, you know, I can also write it as sine x is equal to, and I can take any multiple of that as well. So if you take x, and notice it's pi over 2, right? So if I shift this, okay, so I can also shift this by, you know, again, some 2n pi, right? And then, so this is going to be pi over 2. So if I do that, you know, you can also see the same thing. So let's try it in here. Let's start with x, okay, and then now here. So if I do this, so minus, and then in brackets I'm going to put 2 pi. Now n can be, you know, any integer, so I'll just leave it at that. And then this is going to be just pi over 2. And notice once again, you know, they line up. Why? Because I'm really, you know, shifting it by another 2 pi doesn't really do anything. So translating it by another 2 pi, and you can do the same thing, okay, with the cos and then the sine as well. All right. So that's a translation by that pi over 2. And then lastly, you know, the equivalence that you should kind of remember between these trigs is we kind of should know which ones are even and which ones are odd. So, you know, let's shift this decimals out. I'm going to, you know, kind of tell you how I think about this. So first of all, you know, what does it mean to be even? Well, if you have a function and, you know, your input you change to negative x. If it's even, that means that it is actually equal, okay, to the same input with x. So if you don't remember even and odd functions, okay, so that symmetry between, I'll put up a link up above there. That was, I believe, in grade 11 at some point that you had. So those even and odd functions are useful to know. And then the odd functions, so these ones right here. So if odd functions, what happened was if you put in negative x, then what you would get is you would get negative of f of x. And that's what made it odd. So now in terms of trigonometry, you know, which one is even? And so for this, if you think back of the unit circle, you know, so because really, I mean, the unit circle kind of gives it away, right? I have this, okay, this is not going to be a perfect unit circle, but I just want to do it quick here. Let's maybe shift this more in the middle. And so remember that the unit circle, the x value, right, on the unit circle was always cos x, right? Or sorry, cos of the theta. And then the y value was always sine of theta, right? So let's say, you know, if I go along here and I just keep going in this direction or in the negative direction, okay? So, and here's my theta. than that you could find out exactly what those values were. Now, for an even function, so the even function, which one is it going to be? Is it going to be cos or sine, right? So if you think about it for even, well, we need this. So if I take in, so if my input, okay, is going to be f of negative x, or, you know, f of negative theta, if I'm talking about the angle itself. Well, if I put in negative angle, so if I put in a negative angle in this direction, so this would have been negative theta, like this, okay, if I went on the opposite side, well, what do I notice, right? Which one is going to be the same, okay, as my original? Well, okay, it's going to be the x value, right? So the x value that we have, so that means it's cos theta in here. So cos theta is actually going to be even. So what does that mean? What it means is if you plug in negative x, it's just is equal to, okay, cos of x. And that shouldn't surprise you, because when you're thinking about the unit circle, right, if you go in the positive direction in the theta or in the negative direction in the theta, they give you the same values out. The one that actually changes is the sine, right? Because if we take the sine, then the value is the y, right? So if I go in here, here it's positive, okay, and then here it's going to be negative. So it looks like sine is going to be odd, right? So that's something that you can think about. So cos, okay, is an actually even function, and then your sine is going to be an odd function. So what that means is if you take sine of negative x, well, what it's going to be equal to, so negative sine of x. So that's what you will have. And automatically, because of that, you know, you can also, you know, push this forward into the reciprocals and also into the tangent. So on the tangent side, so what if I had tangent of negative x? You know, is it going to be an odd or is it going to be an even function? But please remember that tangent of negative x, so what we have, let me just shift this over. Well, it's just equal to sine of negative x, right, all over cos of negative x. And, you know, from the ladder, so from the above, I can see that sine of negative x, well, that's actually negative sine of x. And then cos, okay, of negative x is just cos of x, because they're even. So what do I see here? I see that this right here is just negative tangent of x, which means if it's negative, that means the tangent one is an odd function. You can also visualize that, right? You can graph it for yourself and then see it. So that's the kind of last equivalence that I wanted to mention. And you can do the same thing with cosecant, right? Cosecant is 1 over sine. Okay, so you would expect that it's going to be odd. And then with secant, which is 1 over cos, then what you expect is that it's going to be even, which is true. Okay, and I encourage you to, you know, to kind of think about that. So these are the 3 things that I wanted to point out in this part 1 of these equivalents for these trigonometric functions. They're not the easiest to remember. Honestly, you know, I kind of slips my mind. I always have to go back and rethink of the unit circle and then think about what happens in terms of these translations. So, you know, don't feel bad, okay, if you won't remember all of these equivalent ones, okay, because there are actually quite a few. So there are really just 3 parts here. So part 1 is if you're going to be shifting by some multiple of 2 pi. That should not be very hard to remember, actually, because these functions are periodic by 2 pi or by 360 degrees. So that's 1. The second one to remember for you is the translation by pi over 2. So you can kind of in your mind think about pi over 2. And then if you forget, you know, think about the actual graph. You know, so what I often do, especially when I was in university, you know, what I would do about this is because I you know, trying to memorize everything is hard. Okay, so what I would do is I would just think like, oh yeah, that's right. Okay, let me just sketch this thing. You know, I know that sine looked like this, and then I knew that cosine, okay, basically, you know, looked like this. So I had that. And then now, so there you go. You know, I was thinking about, okay, well, if I move my cos, okay, by pi over 2 in this direction, okay, then it's going to be equivalent to my sine, okay? And if I take my my cos and I shift it in this direction by pi over 2, then it's going to be equivalent, right, to that. So I was thinking about it this way. So for instance, you know, to get sine of x, okay, that means, okay, I have to translate, so that's right here, okay, and then to get cos, right, so that is the translation right here. So that's how I would remember that. And then lastly, for this even and odd, this one actually wasn't as bad to remember because I always thought about the unit circle, right? And on the unit circle, I know that cos of theta is your x value and then sine of theta is your y value. So then when I would just kind of sketch this out, I can come up with all of these, right? So I can come up with this, okay, with this, and then, you know, I can manipulate that to remember. So, you know, cos is even, all right, sine and tangent are odd, and, you know, if you remember those, okay, the reciprocal ones, cosecant, secant, and cotangent are the same. Okay, so secant, because it's 1 over cos, is going to be even, okay, and then the other two are odd. So that's part 1 of the equivalent trigonometric functions. All right, thanks for watching. See you in part number 2. Bye, everybody.